Welcome! We're jumping right into an explainer today that's going to completely change how you think about navigating complex code bases, especially when you're working with AI agents. Think about your code base for a second, like a massive, uncharted territory. You wouldn't just drop someone in the middle of the wilderness without a map, right? Well, honestly, that's exactly what we're doing with LLMs every single day. So today, we're exploring a tool that acts as a highly precise technical cartographer for your code. Let's get into it.
Now, I want you to really think about this for a second. How much is your LLM actually reading? When we use modern agentic coding tools, they usually explore a code base by reading files directly. Sure, it's reliable, but think about the massive token cost. On a 1,000-line file, the agent pays for 1,000 lines of tokens just to answer a super simple question like, hey, what methods exist in here? It's literally like paying to read an entire dictionary just to check the spelling of one single word. And the solution? It comes down to a single number, 95%. By giving the agent the structural shape of the code rather than all those raw bytes, you yield a massive 95% token saving compared to reading entire files. No way, right? But it's true. Instead of full method bodies, your agent gets just the signatures and the line ranges. It gets exactly the essential data it needs to navigate, which leaves your token budget completely intact for the actual problem solving.
Section 1. The Agent Token Problem and the Map Solution.
The core mission statement for this tool really says it all. ast-bro exists to make LLM coding agents faster, cheaper, and smarter when navigating unfamiliar code. It directly solves the headache of noisy grep searches and completely wasted context windows. Because, an agent doesn't just want to know what methods exist. It wants to know who imports a file, what the public API is, whether there are any cyclic dependencies, or exactly where a specific login flow lives. Historically, answering those questions took dozens of really expensive file reads.
Okay, let's dive into this and see how it actually ticks. The secret sauce here is AST. AST, of course, stands for Abstract Syntax Tree. This means the tool actually understands the grammar of your code, not just the raw text, so it avoids all those frustrating false positives you get from overloaded names or just random string comments. Under the hood, it uses a brilliant 3-pass resolver. It moves from the same file to a global symbol table and finally to dependency graph disambiguation. And it tags every single edge as exact, inferred, or ambiguous. Your agent gets absolute precision.
And the toolkit this brings to the table is absolutely staggering. It collapses all those agent questions into single commands across 14 different programming languages. You get shape over bytes, it resolves the actual published API that downstream users see, it builds cache dependency graphs, and it maps symbol-level call graphs so you know exactly who is calling what. It even packs a hybrid semantic search using a tiny 64-megabyte static CPU model that runs in microseconds. And the best part? Every single one of these capabilities is wired up through 14 native MCP tools, totally ready to plug right into Claude, Code, Cursor, or your IDE of choice.
Section 2. The version 2.2.0 rebrand. Ast-outline officially becomes ast-bro. So first up is a massive rebrand. You might have known this tool previously as ast-outline. Well, across the entire ecosystem, we're talking Rust crates, NPM packages, PyPy, Homebrew, Nex, it's now officially ast-bro. This means breaking package name changes and every user-facing string, cache directory, ignore file, and schema id has evolved to reflect this new identity. It's really a clean slate for a massive upgrade.
Section 3. Architecture. Let's take a look under the hood.
And this brilliantly illustrates the high-level code map from the release notes. You can see the central hub of version 2.2.0 branching out through these structural golden paths. We've got the crate rename, the legacy path migration, safety caps, proxy binaries, and library extraction, all beautifully interconnected here. It's not just a grab bag of features. It is a completely reimagined grid. So, the most foundational structural change is this. Over 1,200 lines of monolithic logic were stripped straight out of the main executable file and extracted into a proper library structure in lib.rs. Now, why does this matter to you? Well, moving this logic into a library structure means the core engine can finally be cleanly imported and used by other tools down the line. It completely decouples the engine from the command line interface. A real game changer.
Now, with a massive rebrand and a huge architectural shift like this, you might be sweating a bit about your CI pipelines breaking. Don't be. The developers brilliantly included thin proxy binaries. There's one for the old ast-outline name and a neat shorthand one just called SB. These proxies automatically execute right into the new ast-bro binary via a standard path lookup. So your existing workflows, they won't skip a single beat while you transition.
Section 4. The new run subcommand, bringing ast-aware pattern search to your agents.
This structural schematic shows exactly how we got here. That foundational work we just talked about, extracting the library, directly paved the way for the proxy binaries. But even more importantly, it enabled this brand new ast-aware pattern search and code rewrite engine.
Let's break down how this actually works. Powered by ast-grip core, you can now perform complex pattern searches and rewrites across both the command line and directly through your AI agent via MCP. You can search for specific function patterns, run dry run diffs to see what a rewrite would actually look like, or just execute an in-place write. But the absolutely crucial point here is the safety caps. I mean, if you're giving an AI agent the power to rewrite your code, you need serious guardrails. The MCP implementation restricts searches to 1,000 matches and restricts rewrites to a maximum of 50 files. This completely protects your codebase from a runaway agent just deciding to rewrite your entire repository in one go.
For those of you who love a bit of technical depth, there are some really fascinating details about how patterns are compiled under the hood. When you specify the language flag, the AST pattern is intelligently precompiled and reused, which makes the MCP tool just blazing fast. Now, in the spirit of full transparency, there are a couple of very low-severity edge cases in this patch to be aware of. The CLI rewrite currently recompiles per file, which is just a minor performance inconsistency compared to the MCP. Also, the MCP search cap actually checks after extending its matches. That means it can technically overshoot the 1,000 match limit by one file's worth of matches before truncating. It's completely safe, but just an interesting little quirk of the current implementation.
Section 5. Seamless migration. Safe legacy updates for your caches and configurations.
So how do we get there? The answer is a beautifully seamless, automatic migration path. The very first time you run version 2.2.0, it does all the heavy lifting for you, entirely behind the scenes. It automatically renames your old graph cache directories, updates your ignore files, migrates your MCP config entries to the new keys, and updates the local model cache. You don't have to manually move a single file. The whole shebang is handled.
And for the DevOps engineers and tech leads out there, you can breathe easy. If you have multiple MCP tools firing off concurrently, they are not going to race and corrupt your cache migration. Every single one of these automatic migrations is protected by strict process-wide once-lock guards. It is completely 100% thread safe.
Now, what's really interesting about this is how it all comes together. Fundamentally, ast-bro acts as a beautifully precise, highly efficient GPS system for your code base. It takes the dense urban mesh of your logic and draws these golden, high-speed data paths right through it. It serves up the exact coordinates to your LLM agents without any of the noise.
So I'll leave you with this final thought. How much time and honestly, how much money could your AI agent save by simply reading the map instead of blindly walking the entire territory? By dropping the token bloat and adopting ast-bro version 2.2.0, you're fundamentally upgrading the intelligence and speed of your entire coding workflow. Thanks for joining me on this explainer, and hey, happy mapping!